Hello students, my name is Sumit Sagar. I am a PMR PhD student at IIT Palakkad. Today we will discuss lecture 10 of the live discussion section. In this section we will cover lecture 46 to lecture 50 by Professor Ashok Desai, IIT Kanpur, of the subject Introduction to Airbreathing and Propulsion by NPTEL. In this section we will mostly solve some of the MCQs and at the end some of the problems I will solve. So let's start the section. Okay. The type of rotary compressor used in the airplanes is what? It's a axial flow compressor. Okay. The gas turbines use following types of air compressor. Okay. The gas turbine use always a what? Axial flow air compressor. Okay. Okay. So next question. The axial flow compressor is preferred in aircraft gas turbines because of what? Because in fighter aircrafts there is a what? Okay, or any kind of aircraft there is always a what? The space limitations. Okay, so that's the reason why and because of gas turbines all these things are very lightweight, so we are actually using it. Okay, so that's the reason why which implies we are using what? The axial flow compressors. Okay, and in axial flow compressor the advantage is we can actually have a low frontal area. Okay, it can be commercial, it can be cargo. In all the cases this axial flow compressor are used, and the reason is due to the low frontal area. Okay. In axial flow compressor, the exit flow angle deviation from the blade angle is a function of what? Okay. If you see in this question, in the most of the options, blade chamber is a common option. Okay, so mostly if this kind of questions will be asked, then obviously directly you close this C option, because it cannot be the option, because all these three cases blade chamber are the option. So blade chamber is common in everything. Okay, so blade chamber is common. Okay, so now in blade angle, what is the most important thing to look at? Okay, the most important thing to look at in any kind of blade angle is the incidence angle also. Okay, not the space chord ratio. Okay, so incidence angle and the blade angle are more are important in any kind of blade chamber. Okay, so kind of the question they just reversed. Okay, in a blade chamber, the blade angle and the incidence angle are the important parameters. Okay, and okay, so those things actually are there in a kind of axial flow compressors. Okay, an axial compressor gives optimum performance at okay, because axial compressor always requires large volume of the flow. Okay, and because if you see low speed and high speed, an axial flow compressor always works on high speeds. Okay, and when it operates in high speed, it requires large volume of flow. Okay, or large amount of fuel and oxidized mixture. All these things are there. Okay, sorry, means yeah, so it requires more amount of air to compress. Okay, so that's the origin. So answer is A. In axial flow compressor, the flow of air is dash to the axial compressor. Basically, it's flow. It cannot be perpendicular. It cannot be inclined. It's along the direction of the flow. Okay, or more specifically, you can tell parallel. Okay. If the flow of air through the compressor is parallel to its axis, then the compressor is what? Then it's called axial flow compressor. Okay. The degree of reaction in an axial flow compressor is defined as the ratio of static enthalpy rise in the dash. Okay. That's the answer C. Rotor to static enthalpy rise in the stage. Okay. So delta H rotor divided by delta H stage. Okay. Degree of reaction. And this is answer C. Okay. In an axial flow compressor, the ratio of the pressure in the rotor blade to the pressure rise in the compressor in one stage is known as what? It's called degree of reaction. The mass flow rate of air compressed in axial flow compressor is dash centrifugal compressor. Okay. So the mass flow rate of the axial flow compressor is always higher than the centrifugal compressor. Okay. The degree of reaction is usually kept dash for all types of axial flow compressor. Okay. Normally in general we are taking 0.5. If you don't know the actual condition, we will take 0.5. That is the average value. Okay. The axial flow compressor has the following advantage over centrifugal compressor. Axial flow, I already told, axial flow compressor can handle higher amount of air and in higher velocity, so obviously that's the advantage. So what's up? Option A. So now we see the question, one problem. Okay, an axial flow compressor was tested and found that it gave a pressure ratio of 3 atmospheres and a temperature rise of 125 degrees Celsius. A 2000 kilowatt motor was used to drive the compressor. Determine the compressor efficiency and mass flow of air delivered if the mechanical efficiency is 95% and the pressure and temperature at the inlet were 1 atmospheric and 300 Kelvin. A simple question. So in this question the pressure ratio is given P2 by P1 equal to 3. Next T2 minus T1 equal to 125 degrees Celsius. So T2, because T1 already given 300 Kelvin, so 125 plus 300, 425 Kelvin. We got T2. Okay. Now let's draw the TS diagram. For compressor. So 1 to 2 days is the isentropic process, 1 to 2 is the actual process. Because P2 by P1 we already know 3 and the gamma is 1.4 for air. Okay. We'll substitute and find out the T2 dash. So next we have the efficiency of the compressor. T2 dash minus T1 divided by T2 minus T1. 410.62 minus 300 divided by 425 minus 300. Okay. Zero 0.8849 for the efficiency, isentropic efficiency of the compressor is some 88.5%. Okay. So now we have the power and the mechanical efficiency, and we have the whatever the heat change, okay, from T1 to T2. Okay, so we just tell this equation as power conversion equation. So m dot Cp delta T, okay, equal to the pressure, okay, in the inlet, okay, and eta m is the mechanical efficiency. So now we just need to find out the m dot A. So it's a 15 meter per second, 15.124 meter per second, and it I see the compressor isentropic efficiency is 88.5%. Okay, so this is the last question of the section. Okay, this question little lengthy, but yeah, it involves lots of some small questions. Okay, but this question actually gives you a very brief idea about axial flow compressor. Okay. So the question is, a pressure ratio of 1.5 is to be achieved in a single stage of an axial flow compressor. The air approaches the rotor at an absolute velocity of 200 meter per second and at an angle of 12 degree. The speed of the compressor is 8000 rpm and has a mean radius of 30 cm. The determine the blade angle and the blade height if the mass flow is 10 kg per second. Condition at the inlets are stagnation pressure 1 bar, stagnation temperature 300 Kelvin, and the compressor stage efficiency is 95%. When this type of questions are there, so the first job is to always draw the inlet velocity triangle. Okay, inlet or exit, okay, whichever required, just draw it. Okay, so obviously this question we need to draw both inlet and exit velocity triangle. Okay, and we need to find out subsequent parameters. Okay, so that's the idea of this question. So in this question, if you see, the air approaches the root at an absolute velocity of 200 meter per second. Okay, so approaches the root means it's actually at the inlet, and the velocity given is 200 meter per second. Okay. And at an angle of what, 12 degree. Okay, that means this angle it's given 12 degree. Okay. 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 This angle is maybe beta 1. Okay, so this is your inlet velocity triangle. Okay. Okay, so in this type of question, always one very simple thing we always find out, this is the u. Okay, so because in this question, if you see, the RPM is given. Okay, and your diameter you see has a mean radius of 30 centimeters, so the diameter is 60 centimeter, and which is 0.6 meter. So now we have d and we have n, so u equal to pi dn by 60. So we can now find out the blade speed. Okay, So like this kind of question can be asked in your exam also. They will directly give you the d value, which is the mean radius directly given 30 centimeter, and they will give you the rpm. Okay, 8000 rpm, the speed of the compressor they will give. Then they will ask what is the blade speed. Okay, and 4 options will be given. Okay, so those kinds of question can be expected. And as a whole, this kind of question can be asked in any kind of competitive examinations like UPSC, okay, or IES or IAS. Okay. Okay. So u equal to, here u equal to 251.2 meter per second. Okay. So now we have one angle given. Okay, so in this velocity triangle we can see the angle between the VF and the B1 is your what, the flow velocity and the rotor approach velocity. Okay, absolute velocity is, or the inlet velocity at the inlet. Okay, V1. Okay, whatever. So the angle is given as 12 degrees. So in this angle we can have to use this angle to find out the other unknown parameters. Okay, like if we will take the sine theta and cos theta. Okay, theta is maybe the angle is 12. Okay, sine 12 or cos 12 we can take, and we can easily find out the value of what, Vf and Vw1. Okay, and if you see, we have u, and if you have u and if we have Vw1, then we can calculate what, Vrw1. Okay, now we have Vrw1 and then we have Vf. Okay, if you have Vrw1 and Vf, then we can calculate the angle what, beta 1. Okay, which is the inlet blade angle, and that is the question actually asked in the question. Determine the blade angle. Okay, so blade angle means both are the inlet and exit. Okay, so in this way you have to think before solving the question. Okay, so sine 12 equal to Vw1 by B1. Okay, so okay, so next Vrw1 So VRW1 is equal to U minus VW1. Okay, so we have VRW1. Next we will calculate the VF equal to V1 into cos 12. Okay, so VF equal to 195.63 meter per second. Okay, next we'll take, okay, so now we have VRW1 and we know also VF. If you see in this triangle, we have VRW1, the base, and we have also the height VF. Okay, that means if we can take tan beta 1, then actually we can calculate the, and from there we can calculate the what, beta 1. Okay. Okay, so now we have beta 1. So next, okay, so so next we have to go for the exit. Okay, so U is always same. Okay, so now the thing is there is nothing available for exit. Okay, so now how we will relate this inlet and exit? That's the real question. Okay. Okay. So now we just made the exit velocity triangle. In this question, if you see, one thing given here is some temperature values are given. Okay. Okay. So we need to find out the temperature T1. Okay, because in this question no temperature values are given. Okay, so what is T1? T1 equal to T01 minus B square by 2 Cp. Okay, what is T01? T01 is the your ambient temperature. Okay, and this is your V1. Okay, so this is your 300 minus 200 square divided by 2 into, always take in SI unit. Okay, so yeah, if you solve it, you will get T1 value as 280.1 Kelvin. Okay, so now if we have okay, now we have what we have now T1. Okay, so now we need the change in temperature T2 minus T1. Okay, because you see in the question, yes, the first line is the pressure ratio of 1.5. okay, so the pressure ratio of 1.5 given, that means we can find out the delta T, which is T2 minus T1 is equal to T1 into what, P2 by P1 to the power gamma minus 1 by gamma minus 1. I just applied the isentropic relation. Okay, so substitute the values and find out delta t. T1 we know 280.1, it's 1.5, it's 0.4 by 1.4 minus 1. Okay, so the delta T comes out to be 34.4 Kelvin. Okay, so the next will be, so why I am finding this, now you will know why I am finding this delta T. So it's very simple. So eta m Cp delta T, okay, is equal to U into Vw2 minus Vw1. So this is the relation in which we can relate the Vw1 to, we can find out the value of what, Vw2. Okay, and through Vw2 we can find out the other velocity parameters. Okay, so that's the plan. So now we need to just substitute these values. Okay, so what is Vw2? Vw2 is equal to Vw1 plus Cp delta T divided by U into eta m. So what is Vw1? 41.58 plus Cp is your 1005 into 34.4 divided by 251.2 into 0.95. So the Vw2 is 172.326 meter per second. Okay, so now we have Vw2. Okay, and we know u always same for either it's a exit or a inlet. Everywhere this u value is always going to be same. So that means if you see in the velocity triangle, if we have, now we have Vw2 and u is already we know, then we can find out what, Vrw2. Okay, just need to take subtract. Okay, so Vrw2 is equal to u minus Vw2, that is u 251.2 minus 172.326. So from here you can find out Vrw2 78.87 meter per second. Okay, so next we find out tan beta 2. Okay, what is the tan beta 2? Tan beta 2 is equal to Vrw2 divided by Vf. If you see in the velocity triangle, if you have Vrw2 and one more thing also same, that is the Vf for the inlet and the Vf for the exit is same. Okay, so u and Vf are the two things which is same for inlet and exit. Okay, so now we have Vrw2, we already know Vf, that means now we can calculate beta 2. Okay, which is actually the required thing, blade angle. Okay, which is asked in the question. So which is your 78.87 divided by 195.63. Okay, so beta 2 is equal to 21.96 degree. This is your what? Exit blade angle. Okay. Okay. So the next thing what we need to find out is the, because if you see in the question, two things asked. Okay, blade angle, determine the blade angle, we already find out. Okay, and next is there is the blade height. Okay, so this now for the blade height we have to find out. Okay, what is the blade height? The blade height is the change in the diameter between the what, inlet and exit. Okay, so the change in radius. Okay, that is r2 minus r1. Okay, that is the height of the blade. Okay, or d2 by 2 minus d1 by 2. Okay, so d2 minus d1 by 2 we need to find out. Okay, so that is the next task. Okay, that means if d2 and d1 terms are there, that means we need to find out the what, the mass flow rate. Why? Because in the mass flow rate the rho a b term will come. Okay, and that area, from that area term we can calculate what is the area? Area is the pi by 4 d2 square minus d1 square. Okay, so we have the, from that d2 square minus d1 square we can actually calculate, because we know d2 plus d1 by 2, d2 square minus d1 square is equal to what, d2 plus d1 into d2 minus d1. Okay, and we need actually the d2 minus d1 term, because d2 plus d1 by 2 is your what, mean. Okay, and what is the mean value? I think mean value already given in the question. Otherwise you need to find out. Just check. Okay, if you see here, actually I mentioned what is the mean value, dm 0.6 meter. Okay, okay, so that means there is dm value already we have. Okay, so that means we need to find out the m dot. Okay, and for m dot we need the densities ρ2, and we need the what, the va, because it's the flow velocity, we can relate with the mass flow rate. Okay, so that's the plan. So first of all, and then for ρ2 what we need the p2 and the temperature T2. Okay, those two things we don't have. Okay, so then first of all then we have to find out the what, P2, and then we have also T1, and I think we have also the delta T. Yes, we have delta T. So from there, so T2 equal to T1 plus delta T. So T2 equal to T1 plus delta T, and from there we can calculate T2. Okay, so all these things we will just now quickly do it. So okay, so the pressure at okay, So if you see, we need to find out P2 by P1. So P1 we found out, so P2 equal to what, 1.18 bar. So 1.5 into whatever the value we find out from P1, just multiply and find out P2. Okay, so now we have P2. Then what we will do, we just find out T2 is equal to T1 plus delta T, okay, which is 280.1 plus 34.4. so T2 is equal to 314.5 Kelvin. Okay, so what is the density? P2 by RT2. P2 is 1.18 into 10 to the power 5 divided by 287 into 314.5. so what is rho 2? Rho 2 1.3 kg per meter cube. So now we have rho 2. So next we will find out what, your m dot. So the m dot is equal to rho 2 into pi by 4 d2 square minus d1 square into what, flow velocity. Okay, why I am just directly calculating m dot? Because if you see in the question, one hint is given in the question, the mass flow is 10 kg per second. This is the best hint in the question. Without this we cannot find out the answers. Okay, so just to substitute the values, 10, 1.3 pi by 4 d2 square minus d1 square. What is Bf? 195.63. so here you can find out d2 square minus d1 square by 4 is equal to 0.01245. okay, so what is d2 square minus d1 square? We can just make it like this, d2 plus d1 by 2. so next d2 minus d1 by 2, okay, is equal to 0.01245. okay, so what is d2 plus d1 by 2? It is your dm into, let's write down d2 by 2 minus d1 by 2, okay, is equal to 0.01245. okay, what is gm? 0.6. okay, so d2 by 2 and d1 by 2 I just write down batch what, r2 minus r1, which is 0.01245 divided by 0.6. okay, so what is this value? 0.02075. okay, so meter. okay, so is equal to, also you can write down in terms of mm, 20.75 mm. Okay, and this is your height of the blade. Okay, this is your answer. Okay. So whatever the question asked in this section, the blade angle and the blade height, with both things we find out. Blade angle means both inlet and exit we need to find out. Okay, and if you see blade height, I also find out the what, the blade height. Okay, so all the values are we just find out. Okay, so thank you very much for the attending the section. If you are attending the recording also, thank you very much. If you have any doubt, you can ask in my comment section of my YouTube channel, Sumit Sagar Hota. And if you have any course related doubts of the lectures, you can ask in the NPTEL question and answer forum. Okay, so we'll meet next week for the week 11, and we have a summary section also for this course on Monday 6 to 7, 1 hour summary section. Okay. So not this Monday, after the 12th week will be over, then I have this one summary section. Okay, now next week will be the 11th week. Okay, next 12th, and then after that this summer sections will be there after the completion of all the weeks. Okay, so thank you very much for attending. Stay safe, good night, and happy learning.